In this video, we're going to discuss graphic user interface. Sometimes we call this GUI, G-U-I. And in the Java world, the most current version of the graphical user interface libraries, of which there are 3 versions. The most recent version is called JavaFX. And we will discuss that. That's part of this PowerPoint right here. And as you can see, there are actually 3 chapters in the book that are devoted to this, chapters 14, 15, and 16. So we're going to cover a few of the examples from these chapters. In chapter 14, we'll get into the basic overall architecture underlying JavaFX and go through some examples of that. Chapter 15 will focus a little bit more on event handling. So what happens when the user clicks a button, or what happens when the user selects something, those kinds of things. And then there are going to be some more detailed examples in chapter 16. And if we look at the Liang examples in our NetBeans project, you can see that chapter 14 has a whole bunch of examples, as does chapter 15 and chapter 16. Obviously, we're not going to go into each and every one of those examples, but they give you, there's a good rich variety of graphical widgets that can be explored, and I encourage you to experiment with these and get a feel for it. So if we look at the history of Java, which was released by Sun Microsystems back in the mid-1990s, I think it was 1995, and originally it had something called AWT, Abstract Windows Toolkit. And you can still access AWT, and some of AWT actually went into the later version called Swing. AWT is the oldest version of these Java component classes, and we talk about Java components, we're talking basically about the various types of widgets in a windowing environment. The way that we've interacted so far with our Java programs has simply been command line interface using the standard input stream and the standard output stream. But of course, in the real world of applications, that's not generally the way things are done. Generally, it's kind of a Windows environment where you have menus and buttons and list boxes and things of that nature. So the original version of that was AWT. It was really relied on something called a peer architecture, which means that it was the operating system that we were running on that determined the look and feel of what these widgets, these buttons, these windows, etc. would be like. So a Java application that ran in a Microsoft Windows environment would not look exactly the same as if it was running in a Mac OS environment or in another environment. And so that was a little bit annoying to users. And so shortly after AWT came to the fore, another couple or 3 years later, I think it was in 1998, that the Swing classes came in. In this case, we're not relying on the operating system to draw the components. The components are drawing themselves. AWT is considered to be what's called heavyweight. Swing was considered to be lightweight. And so Swing was the predominant GUI environment for about a decade. And then around 2008, JavaFX was introduced. This is the newest version. It's a bit easier to use than the earlier versions, and that's what we're going to be focusing on, JavaFX, in this class, and that's what the textbook focuses on. And you will notice that there are a lot of packages that have JavaFX as part of their names. So let's go take a look at the API documentation to give you a little flavor of it. So once again, from Canvas, I have a link that takes us to the API. And if we look at the all of these packages, there's a lot of packages that begin with Java, but there's also packages that begin with, say, JavaX. A lot of these packages had to do with the Swing classes, as I said before. So there's javax.swing and then a whole lot of other sub-packages of that. And then There are also JavaFX packages. I guess we don't see them in the documentation, but I can Google it, JavaFX documentation, and then there is a separate bit of documentation specifically for that, and look at all of these packages that are the JavaFX packages. So we're going to focus on JavaFX in this video. So let's get a feel for how JavaFX works. In the basic structure of JavaFX, you have a JavaFX application. So there is a class called application, and this is an abstract class. So when we create a GUI application that makes use of JavaFX, we're going to override that abstract class. Remember, we have talked about abstract classes before, and we also talked about interfaces before. And we got a lot of experience working with interfaces when we were doing the database stuff. And now we're going to have some experience working with this abstract class called application. And this class has a method called start, which is an abstract method. And it takes as an argument a stage. So stage is another class, part of the JavaFX class library. And so an application, when it starts, will have a stage, and that stage can contain scenes, and those scenes in turn will contain nodes of various types. So we have this containment hierarchy where you have an application, which involves a stage, and the stage is going to involve one or more scenes, and the scenes involve one or more nodes. For example, one kind of node might be a button, and there are, of course, many, many other kinds of nodes as well. So the very first example, this very simple example called MyJavaFX. And here's our application that we're creating. And our application is going to be a subclass of application. So our application is called MyJavaFX. That class is called MyJavaFX, which is a subclass of application. And you'll notice that we're importing a bunch of these classes: application, scene, a button, which is part of the javafx.scene.control package, and then stage as well. And we are overriding this method called start, which is a method of the application class, and it's taking a stage, and we're creating a button, and we're creating a scene that contains that button. And for the stage, we're setting the title. That's going to be what's going to appear on the Windows title bar. And we're setting the scene into that stage. And finally, we're showing it. Now, you'll also notice that this application has a main method. This class has a main method. Certainly, all the classes that we have worked with before, if they were going to be an application, if they were actually going to be a program that you can run, as opposed to just a class that's instantiating an object or something, then you would have a main method. Now, in reality, application classes that extend application, don't really need a main method unless you're working with them from an IDE like NetBeans. And so the only reason we're seeing main methods in these samples is that we're doing these from within NetBeans. If this was just something that we were running by double-clicking on an icon directly from Windows, as often is the case, we wouldn't need a main method for that. But our examples will all have main methods simply because we're running them through NetBeans. Here I'm looking at the JavaX.application package. And in that package, we see the application class. And when I select that, we'll see that that application class, which is an abstract class, as we see here, and if I scroll down a little bit, we'll see that one of the methods is start, and it takes as an argument a stage. If I can look at what a stage has, I can click on stage and see that's another class, and it also has its own functionality, etc. So I guess the best way to illustrate this is to actually run this, and let's see what we have. I'll go ahead and run it. And that's what it looks like. Here's a window. There's all this windowing functionality. You can kind of expand it and shrink it. You can, all of the functionality for minimizing and for maximizing, etc., is all there. Within there, you'll notice I have this word OK here, and really that's a button. And if I click on it, you can see that the button's fairly big. In fact, the button is taking up the whole space of this scene that is embedded in the stage. And so, as a result of clicking that button, nothing's happening yet, but we will see stuff happening when we start to deal with event handling. And in order to terminate the application, I can just X out, and now this application has been completed and terminated. So again, to look at the steps that took place in our start method, we instantiated a button, and we pass as an argument the label that that button is going to have. There are different versions of button instantiations that we can do. In fact, buttons can have images just as well as they can have labels. We instantiated a scene. We specified the height and width of the scene. That's these two arguments. And we also said that that scene is going to contain this button. And then for the stage, we set the title. And we also set the scene for the stage. And finally, we showed it. And those were the steps that took place, causing the behavior that we saw. So in the next example, we see that you can actually have an application that involves more than one stage. Certainly the primary stage is what's passed as an argument to the start method when the start method gets invoked. And by the way, how does the start method get invoked? It's getting invoked based on stuff that's happening up in these higher level classes. So here was yet another case of polymorphism taking place. And so even though in the class library there's no knowledge of a class called MultipleStageDemo, or for that matter of a class called MyJavaFX, all we know about is that there is a reference to some kind of application. That application reference, whatever is being referenced there, is going to be a class that extends application. It's going to have a start method, and so somewhere up here in this higher level stuff that's taking place, that start method is being invoked. I can even illustrate this by running it in the debugger. So I'm going to debug this. I've got a breakpoint right here in the start method, the very first statement in the start method. Look at all of this stuff has taken place under the hood before we even got up to start. Start is where we're at currently, but was called by this, which was called by that, which was called by that. You can see just how much is taking place behind the scenes, if you will, and just to get us to the point of starting our application. So to illustrate this multiple stage demo, I'll run that. And you'll notice that we have two different stages here. Here's a stage, the second stage, and here's a stage. This stage that is titled MyJavaFX was not created by us. It was given to us from above. That's the primary stage. And we set a scene with a button and we specified its width and height. Notice also we're able to change the width and height if we want to. Originally it was 200 by 250, but we can always just dynamically change that. And we saw another stage here being created. We instantiated a stage here, and we gave it a title, second stage. And we created a scene, and in that scene, we created another button, so that was passed to the scene constructor along with the 100 and the 100, and that's why we have this one. Now, if I click on this, it doesn't terminate the application. The application is still running. It's only when I click on the primary stage to close the primary stage that the application terminates. As a matter of fact, if I did it in the opposite order, so let's say I clicked on the primary stage here, and that also did not actually terminate the application. It was only after I exited the second stage that the application actually terminates. So this figure from the textbook gives you a little bit of an idea again of the hierarchy. We have our stage containing our scene, which is containing nodes. Some of those nodes might be parent nodes in the sense that they themselves might contain other nodes. So here's the node class. A subclass of node is parent, or I should say this is a node interface. You can see by italicizing that this is an interface. A sub-interface is parent, and control is a sub-interface of parent. And pane is also something that implements node. So you can see that hierarchy. And these panes have to do with what are called layouts, and we'll see different kinds of layouts, how we can arrange our various components, our buttons and whatever, in flow or in grid or in border pane or in stack pane or horizontal box or vertical box. We'll see all of these examples in a bit. But other kinds of controls, labels, text fields, buttons, checkboxes, radio buttons, text areas, all of these are subclasses of this control, which is, did I say that it was an interface? I should have said that these are all abstract classes, not interfaces. So control is an abstract class. Other kinds of nodes include shapes, lines, circles, etc. Something called image view as well. Notice that a stage has a scene, so a scene is a part of a stage. We've got this composition relationship. And a scene contains a parent as well, as we can see here. So there's another composition relationship. So let's look at some examples of how we can organize our nodes in a container using a pane. So the base class for all the layout panes is called pane. And subclasses are stack pane, flow pane, grid pane, border pane, etc. So we're going to see an example of a button that's actually in a pane now. So here we have our various classes that we're using. Notice that there we still have our application, we still have our scene, we still have our stage, we still have our button, but we also have this thing called a stack pane. We're instantiating a stack pane here. The pane class has a getChildren method, and so we're able to add child components to that pane, and we're adding a button to it. And then what are we putting into the scene? We're putting the pane into the scene, not the button directly into the scene, but the pane into the scene, and we're specifying a size. And again, we're setting the scene for the stage, we're setting the title for the stage, and we're showing it. And this is what things look like as a result. So here's the ButtonInPane. Here we run it. That's what it looks like. So now this button is kind of not taking up the whole thing, as we can see. So we have a little bit more maneuverability of how we organize things. One thing to point out also is that you will see that in all of these examples, in our main method, we're calling launch. Launch is actually a method of the application class, and that's what's setting things up initially and then ultimately calling start, which is where we're doing the major stuff that we're doing. The next kind of layout is a flow pane. And here we have a number of components here. We have a label, we have a text field, we have another label, we have another text field, another label, another text field. So we wind up with 3 labels and 3 text fields here. Let's take a look at that code. So here's our show flow pane example. We have a label, we have a text field, and we have a flow pane. That's our layout. We don't have any buttons in this example, but we do have labels and text fields in this example. And we'll look at some of these other classes that we're making use of. I'll go ahead and run it. And here we have it. And notice the behavior here. As I widen it, these fields, the positions of these fields are adjusting dynamically. So that's the thing that these layout managers enable us to do. They allow us to kind of dynamically replace components to fit best in the arrangement of that pane. And the flow pane, the way that they're arranged, is essentially left to right, and if narrower, then wrapping around, as you can see. And that's the behavior that takes place. And left to right in the order in which they were added to the children. Let's take a look at that code. So here was where we had created our flow pane. This set padding with these insets. So the set padding enables us to ensure that there's going to be some padding on the edges. The H gap and the V gap is ensuring that there is some gaps between the elements that we can see. We'll play around with those and see how we can adjust that. And then here, with the getChildren method, add all is adding in that order the label, the text field, another label. Looks like we're making another text field as well. And so we're adding two more, another label in this new text field. Well, it looks like that new text field was specified. This was a text field for the middle initial, was specified to have a specific width laid out. The set pref column count is specifying we only want one column to be visible for that particular text field. And we're able to adjust that as well. We're able to control that as well. And then same sort of thing. We created a scene. We put our pane there, our flow pane there this time. And then we set the title and we showed it. So this use of insets and this use of set H gap and V gap allows us to control things. So that's what it looks like with the originals. Let's see if I try doing a little bit different with our insets and our H gap and our V gap. Let me set my insets to maybe 20 for each of these. And I run it. And you should be able to see that there's a little bit more of a gap here than what we had here. 20 pixels instead of whatever it was, 10 or 12 or whatever. And let's set my gaps, my horizontal and vertical gaps here. And we should see when I run it like that, we're having a heck of a lot more in terms of gapping than we used to have. But still the same behavior with the wraparound and with left to right. So that's a flow pane. So the next layout we'll look at is a grid pane layout. So it has a little different behavior. We're not going to have any wraparounds or anything. It'll be actually laid out as a grid with rows and columns. And here we can see the grid pane. The grid pane has a set alignment method, and we're looking like we're centering things. Again, padding with our insets, horizontal and vertical gapping, as before. And we are specifying our columns and our rows for each of our labels. So the label first name is going to go into column 0, row 0. The text field for the first name is column 1, row 0. The middle initial label is in column 0, row 1, and the text field is in column 1, row 1, etc. You'll notice that on that last row, there's 4 rows here, 0, 1, 2, and 3. In that last row, we're putting the button only into the right place, position 1, column 1. So the left place, which doesn't have anything, will basically be blank. And if I run it, and that's what it looks like, no matter what I do, it's always going to be in that kind of grid format, as we can see. So here we had an example that had text fields and labels and buttons, and with a slightly different kind of layout. And I can control the positioning here. So this POS class has some static member variables. One was called center. And let me try this one. Let me try top left and see what the behavior is going to be when I do that. And if I go ahead and run this, and now if I want to expand out on things, you see it's not being centered, it's staying right there in the top left. So that kind of behavior you can control. Another interesting kind of a layout is a border pane. Now in a border pane, you basically have 5 places where you can put your components, top, bottom, left, right, and center. And we'll see some behavioral elements of that when we resize. I'll go ahead and run that. So when we run the border pane example, notice what happens when I go left to right. When I go left to right, the top and bottom, the top, center, and bottom all get wider, but the left and right remain exactly the same width. And notice what happens when I go up and down. The top and bottom's heights remain the same, but the left, right, and center width heights change. And so, as you can see, it's kind of the center that's dominating the sizing here. So that's the behavior of a border pane. In this example, we actually see the creation of a subclass of stack pane where a label was added, some styling, some padding. So you can make panes that are subclasses of panes. And that's what was done in this example right here. So there's a lot of different ways that you can control the look and feel, the behavior, the arrangement of your components in your scene of a stage of an application. So here's another interesting example to look at. This one is using HBox and VBox. And in this case, it looks like we have our application class with its starts. We have a method here called getHBox, which is instantiating an HBox, setting some padding and some styling. And this is an HBox, so things are going to come out horizontally here. We're putting a button and another button and an image view which contains an image. So here again, we have some other kinds of GUI components that we can be adding. So we're adding a button, another button, and an image view which contains an image. And where do we get that image? From this subfolder here called image, us.gif, and then we're adding that. So that's our HBox. And in our VBox, what do we have? Well, it looks like we have an array of labels, and we're looping through that array of labels, adding it to the VBox. So we're going to have those labels vertically, and we're going to have these buttons and the image horizontally. And you'll also notice that we also are putting our HBox at the top and our VBox underneath or I should say at the left, we created a border pane. We set the top of it to be the H box. We set the left of it to be the V box. Let's see what kind of behavior we get on that. So our primary stage has this border pane. The border pane, in turn, has an H box and a V box. The H box, in turn, has these buttons and image, and the V box has these labels. So you can see this entire containment hierarchy. So I'll go ahead and run it. And here we have it. So you can see we have our border pane here. What do? We put in the top, we put this. In the left, we put this. This is an H box, which has a button and an image. This is our V box, which has the word courses, followed by all of these items right here. Notice how we got a little indentation here, and not there. So if you look at the V box, we added courses as a label, and then we instantiated all these labels as an array of labels. And notice the setting of the margin before we added a course. And that's how we got this indentation effect here. Notice what happens if with the border pane, instead of saying set top for the H box, I say set center. And instead of saying set left for the V box, I say set right. And if I run it now, we have it laid out a little bit differently. And chapter 14 has a lot of other very nice little examples. I encourage you to play with them a little bit. Here's show circle, for example. And we see what happened with that. So various shapes, ellipse as well, squares, whatever, lines, polygons. This is kind of nice, isn't it? Nice little effect. So play around with those things. And now we're going to talk about how we respond to when the user does something, when the user clicks a button, when the user selects something of that nature. So what we have been doing so far with just the command line interface is often referred to as just procedural programming. But what we're doing now, what we're starting to do now, is often called event-driven programming. So where code is executed upon the activation of events, such as a user click or something like that. Most events are user-generated events. There can be other kinds of events that trigger actions as well. If we were going to be doing something like in a network environment, if we were going to be coding in a network environment or an internet environment, well, one example of an event might be that we get a triggered message from somewhere in the web, somewhere external in the web that comes to us. And that can trigger something. So events are not necessarily user-generated events. But in what we're going to be covering is going to be about user-generated events. The user clicks a button, the user selects something from a list, the user checks a checkbox or unchecks it, those kinds of things. So that's what we're going to talk about, how to handle those kinds of events. So here's a typical scenario. You have some source object, which could be, for example, a button. And then you have another kind of object called a listener. A listener object will process that event. And of course, really, we have another kind of object called an event. That's an object. Everything is an object. Java is an object-oriented language, after all. So we've got event handlers, we have events, and we have the source objects that generate the events. So here's a nice little definition of an event, a type of signal to the program that something has happened. So basically, in an event-driven architecture, in an event-driven program, most of the time the program is just sitting there, doing nothing, listening, waiting for an event to take place. And when the event takes place, that triggers an action. there are a bunch of different kinds of event classes. These are the JavaFX event classes. Recall that there was also swing and AWT, and there are event classes that you can work with in the AWT library, but we're going to be focusing on these kinds of events. So kind of event is the granddaddy of them, and action event is one that we're going to see a lot. There's also input event, window event, different kinds of input events, whether the user does something with the mouse, such as, for example, click, or such as drag, or such as even move the mouse. All of those things are events that a mouse action might generate some kind of action from your application. And then a key event, which means either I'm pressing the key down, or I'm releasing the key, or both the press and the release of the key can also be another kind of an event. So let's look at our first example here from chapter 15 now, HandleEvent. And you will notice that we've got these two handlers here, and they are of a particular class. So we're instantiating a handler of this class, OKHandler class, and we're instantiating a cancel handler class. And notice what both of these two things are doing. They're implementing. What are they implementing? Well, if you're implementing something, you got to be implementing an interface, and here's the interface, EventHandler, that they're implementing. And this particular kind of event handler is an action event. Now, this is not something you're going to have to worry about doing yourself. This is an example that's showing you what you used to have to do prior to the existence of Lambda Expressions, which we're going to talk about shortly. So basically what we have here are listeners. These are listener objects, essentially, that are going to listen for an event, which is this event on clicking the button. So when clicking a button, that's generating an action event. Here's another button that got clicked, the cancel button, that's generating another action event. And these are the two handlers that are going to be dealing with each of these two kinds of events. Other than that, what we see here in this code is what we've seen already. We've got our own application class as extending this class called application, which you'll recall from our previous video. We're overriding the start method. We've got our stage. We've created an HBoxPane right here. So all the rest, all this stuff is, for that pane, we're adding the OK and the cancel buttons here, this add all. You've seen that sort of thing happen before. We've got our scene set up, all the rest. But the new stuff here is the event handler. So here we are in NetBeans. We see the HandleEvent class. Let me run it for you. And you see that we have our horizontal pane, our HBoxPane with the OK and the cancel there. If I click the OK, you can see that that triggered an event. If I click the cancel, you can see that that also triggered an event. So we had, in this example, we had instantiated two different event handler classes. And we actually declared those two different event handler classes. And each one of those was implementing this event handler interface and had to therefore override the abstract method handle in order to be able to do what needed to be done. And in this particular case, the kind of event was an action event. This kind of syntax right here might be something that you're not really used to. This is the notion of what's often called a generic, where you might have a class and you have different kinds of expectations for that class about what data types there are involved with that class. And in this case, the event handler is dealing with an action event as opposed to some other kind of event. So let's take a look at what event handler is and what the action event is, and we can look in the documentation to see those kinds of things. So here I am in the JavaFX documentation here, and I went to the javafx.event package, and it has a few of these interfaces, one of which is called EventHandler, which is what our class that we've declared in that example is implementing. It's implementing EventHandler, and this particular interface has something called a type parameter. Sometimes you can, when you declare a class, you can specify that it's expecting to work with certain types of other classes. So there's this generic EventHandler interface, but you can be specific about what kind of event your own EventHandler is going to be working with. And in our case, it's going to be working with an action event. And if we look at action event, we can see action event right here, and there's an action event. Action event is very typical for something that happens when the user clicks a button. And again, to show you some of the typical events that you can have, well, action event was one of them. But it's not the only one. There's all kinds of events that can take place. And again, to kind of associate that with the kinds of objects, source objects involved, buttons generate action events, text fields generate action events. All kinds of nodes, whether they're buttons or anything else, can generate these kinds of mouse events. Lots of mouse events can be generated by pretty much anything, and I can have the same source object generating different kinds of events. Text fields, radio buttons, checkboxes, combo boxes generate action events. But we can also have mouse events, we can also have key events. And this whole process of how user actions trigger events that are listened for and are handled, if you will, it's often called the delegation model. So here's a diagram that's showing that. So we have a particular kind of source object, such as a button. It's going to have its own internal method for identifying what's going to listen for what the kind of event that takes place. So here was a generic thing, but here is something specific for when the user clicks a button. So there is actually a set on action method of the button class, which allows you to specify who's going to be the listener. And that listener is going to be something that is going to be an instance of a class that is implementing this event handler method of a particular type of event. And this custom listener class right here that's being depicted in this diagram, that's the classes that we saw in the previous code listing here. So this is a class that implemented EventHandler. Here was another class that implemented EventHandler. In both of these cases, they were implementing EventHandler expecting to look for an action event. And that's what we see here. And also note that for the button, there was a set on action method here. And what are we passing? We're passing that particular handler that we're instantiating of this particular class. And that's what this diagram is showing right here. So you got a source object. The user generates an action on that source object. That source object, we specified a listener that's going to listen for that particular kind of action. And that listener is going to do something. And that listener is implementing this interface. And that's what we saw happening in the previous example. Now that's a lot of coding to do, and it used to be that that's pretty much what you had to do. If we were working with swing classes, we would be doing something very similar to that. But in Java 8 and beyond, started to bring into existence the notion of something called a Lambda expression. You can think of a Lambda expression as being like a method, as it says here, an anonymous method. And with a concise syntax, so you're not going to have to worry about doing a lot of things you have to do with method declarations. And you can use that as a substitute for all the stuff that you saw in that previous example. And here's your Lambda expression basically right here. What we have here is, here's our set on action method. And E is the event that would take place, and this little arrow, little symbol here with the hyphen and the angle bracket here, and then this open curly Q brace and close curly Q brace, that's basically your method body right in there. So it's a way of kind of a shortcut notation for creating a method. And so let's look at examples with Lambda expressions. So this code shows you a variety of ways of doing your Lambda expressions. So notice we're not declaring any new classes or anything like that, as you can see here. But we are, for each of our buttons here, we are invoking the set on action method. So remember, that set on action method is going to specify what is the event handler that is going to do stuff when the user clicks that button. And here's a variety of different ways of expressing it. Action event E, or just E in parentheses, or just E without the parentheses. And then your little kind of arrowy symbol here, hyphen and an angle bracket. And then in these cases, you've got in curly Q braces, and closing off this whole thing. Notice how this end parenthesis here is closing off the open parenthesis of set on action. So all of this stuff right here that's in between is the argument that's being passed to set on action. Same thing here. We're calling set on action, the open parenthesis, the corresponding closed parenthesis. So everything in between is this argument. And what is this argument basically saying? It's saying that this event is going to generate that action. That's what a Lambda expression allows us to do. Very nice way to kind of save us on coding effort that we would have had to have done basically something more like this, with the whole class declaration taking place otherwise. Now, there were a variety of ways of doing this. We could have done this with anonymous classes. We could have done this with anonymous inner classes. There's all kinds of ways that we could have done this. But prior to the invention of Lambda expressions, or prior to the inclusion of Lambda expressions in the Java language, which took place when Java 8 came about, we weren't able to do this nice little concise syntax. So here in NetBeans I have the LambdaHandlerDemo up. Let me run it. You can see that it's going to behave just as we would hope it would behave. I'm clicking New, I'm clicking Open, I'm clicking Save, I'm clicking Print. Each one of those actions had their own little Lambda expression that was affiliated with it. One example in chapter 15 that's kind of a nice example is this loan calculator. And if we look at the loan calculator, we can see that, well, let me run it first. This looks like a grid layout, don't you think? And it looks like we've centered the grid layout. We've got 1, 2, 3, 4, 5, 6 rows. We got 2 columns. For most of the rows, the left column has a label and the right column has a text field. And for this last row, the left column doesn't have anything, and the right column has a button. Let's see what happens if I had a 10% interest rate for 20 years, and I was taking out a $100,000 loan, and I click calculate, and voila, it's calculated stuff for me. And here's our button, BTN Calculate, that we've added to our grid pane, as you can see. And here is the button itself. Looks like it's a member variable of our class here. We've instantiated the button. And notice the Lambda expression that we used here. In this case, the Lambda expression was when the event occurs, this method is going to be invoked. Well, what's the method? Well, here's another method that we just created called calculate loan payment. So here we basically said in our Lambda expression that a particular event is going to cause the calling of calculate loan payment. And that's exactly what just took place. And there's all kinds of neat examples in this chapter. Here's one called US Map. Let me run that one. This is involving images and things of that nature, map panes and whatnot. Look at that. Look at all the cool stuff you can do. This is an event. I'm clicking on a particular state, and that's an event. Now, Chapter 16 has a lot of nice little examples as well. And in Chapter 16, you can explore different kinds of components. Of course, here we have the button. Go ahead and run this button example. Looks what happens when we, oops. Okay, it's a nice one. Let's do another one. Let's do the, which one do I want to do? The radio button demo. So this is a different kind of component called a radio button. Look at this. Looks like we have a border layout going on here, as you can see. Let me click right here. These are radio buttons. The idea with a radio button is going to be one or the other, right? It's not going to be more than one, as opposed to a checkbox. Here we can have both bold and italic. It doesn't have to be bold or italic. But with radio buttons, the idea is going to be one or the other. And then, so we got buttons here. So we have a border layout. We have all these different kinds of events taking place. When the user checks a box, when the user clicks a button, when the user selects one of the radio buttons. So here is the code for setting the on action for the radio buttons. So here's another beautiful example of reuse of code. So let's look at this checkbox demo. And if I run that, there's our checkbox demo. So a lot of the border layout stuff was embedded right in checkbox demo. What did radio button demo do? Radio button just added the radio buttons to it. Same exact thing, but we have an extra pane here that is put in the west part of our border layout that has the radio buttons. Want to play some tic-tac-toe? Let's do that. So here we have something that looks a lot like a grid layout here. We're actually a border layout that contains a grid layout, I'm going to guess. Here we are playing tic-tac-toe. Yeah. And all of those things, you can take a look and see how event handling is taking place, how shapes are being done. Play with this stuff, explore it, and see what can be done. Now, the last thing I'd like to do is I'd like to tie in this GUI stuff with what we learned about database, and this is what's going to be the two main skills that you're going to bring to bear for this last assignment of yours, where we're building a database application that involves a GUI interface. And so we already talked about database stuff, and remember in our database example project that I had given you before, I gave you the entire project, and the reason was that it had to have these jar files that enabled you to interact with the database. This is often called middleware, what's being given to you here. Middleware, this is what allows interoperability between your application and different kinds of services, in this case database services. So certainly we did that. But now that we have some graphic user interface experience under our belt, let's see if we can see what we can do with database and GUI together. So let me just run this example for you. We're connecting to the employee database that we have looked at already. I have a combo box here, and I have the names of all of the projects: accounts receivable, employee records, business analytics, and accounts payable. So if I look at employee records, and then I want to see what the description is, I click this button, and voila, there's the description. So just to remind you what this looks like here, this is our projects table. There's a project ID, the name of the project description, the start date, and the end date. So let's take a look at our code and see how we made that happen in our example here, where when I select different projects, we get the correct descriptions. Keeping track of ledgers, business analytics, analyzing data in the organization, etc. So let's see how we made that happen. So here we are in our code. Of course, we're importing a bunch of stuff from JavaFX. We're also importing something from Oracle. Remember, we have to make use of that data source here. So we're combining database with GUI here. I created and I instantiated a combo box, and here we have another example of the use of this funny little syntax. And again, the notion of this is a type parameter. So what that means is that this combo box is a combo box that's going to contain strings. I could have specified that it's supposed to contain other things if I wanted to, but we're specifying that it's going to contain strings. This particular, we have a flow pane here, as you can see, and we have set up our connection to the Oracle database this way, similarly to what we have seen done in previous examples. Remember the employee database that I specified that the name of the user was emp, and also its password was emp, so we're passing the user ID and the password to this get connection method. We did the same exact thing in a previous database example. And we're going to have a label, and we're going to have our combo box, and let's take a look and see. Let me run it again here. So you can see it's a flow pane. Can you see that? And here's our combo box, and let's see how we set up this combo box here in our code. In order to set up the combo box, we had to get the data from the database. In order to set up the combo box, we had to get the project names. So what did I do? I did a query. And what did I do? Each time in my loop, as I was looping through the project names based on that query, I added that to the combo box items. And that's the code that was done to do that. So this code right here, which involves querying the database, was how I got stuff put into that combo box. And that was taking place in the start method. That again, we're overriding this start method of the application class. Let's take a look at this button. So we had put this button here, set on action. There's our Lambda expression. In our Lambda expression, we're specifying what is the method that's going to be invoked when the user clicks that button. So let's see what that method does. Get project description. And here's that method. What am I doing? For the combo box, I'm obtaining the current value. Well, what did that mean? That meant that whatever the value was that I had there, this business analytics is now the current value. Now it's accounts receivable that's the current value. So I'm getting the value. At the time that I click the button, I'm getting the value. And I'm doing a query. Look at this query. I'm actually creating a string that has the query. Notice the single quote here that I have to put. Remember, a literal in SQL is supposed to be embedded in single quotes, so don't forget that when you do your coding. So the string that's generated is basically a concatenation of this, and not forgetting the single quote here, and then whatever the value was that was obtained from the combo box, and then an end single quote. And here's our execute query method of the statement class. Remember, we did that actually statements and interface, but there was a class that was generated by this driver that is part of this driver, that's this jar file that we've got in our NetBeans project that's implementing the statement interface, implementing the execute query method of the statement interface, basically performing the query, giving us back what? A result set. And then that result set would have only had one value in it, right? One row in it. I mean, it's there's only one row for each project name. So I just went to next, and then I, for the label, set its text. So this is an example of how we can programmatically manipulate the content of different controls. So accounts receivable, get project description, that's the text for accounts receivable in that label. So all of this stuff is going to be relevant for your next assignment, and I believe we have covered all the material having to do with graphic user interface and database that I wanted to cover for this semester. So now the ball's in your court. Finish your work.